until now, and many molecular targeted agent has been developed in gastric cancer field. However, almost all molecular targeted agents failed in overall survival benefit. For example, MET, EGFR, HER2 except for trastuzumab, Anti-Angiogenesis except for ramucirumab, STAT3, PARP inhibitor, and so on. And FGFR also, several trials failed in overall survival. However, now very focusing on FGFR abnormality patients enrolled in clinical trial, FGFR is very promising, and Claudin 18.2 is also promising in first trial as a randomized P2 trial, very good data. And has a newer agent, DS8201A, Japanese called NHATS. NHATS is a character name, and very promising DS8201A for HER2 positive gastric cancer. Also, HER2 low expression of gastric cancer is also active. And HER3 and so on is attractive. However, now under evaluation. At this moment, the very limited impact in gastric cancer field, but now is a very attractive agent is developing now in gastric cancer field, and several years later, I hope NGS sequencing or the many biomarker direction is become impact of gastric cancer field.
In addition to some of the predictive biomarkers that we've just been discussing with respect to immunotherapy, like MSI-high, PD-L1 status, and others, there are a number of emerging biomarkers that may render some predictive utility, both for immunotherapy or other targeted therapies. Just speaking with respect to immunotherapy, potentially EBV positive tumors, which have extremely high expression of PD-L1, they may derive some benefit. I think it's very rare and it's hard to get a robust data set around that, but that's a potential. Another potential one is tumor mutation burden. And so we know that MSI high tumors have extremely high tumor mutation burdens, but other tumors that are microsatellite stable have high tumor mutation burden. And so I think that data are emerging and more studies are needed to really define whether tumor mutation burden independently will help to predict a benefit from immunotherapy. For example, in microsatellite stable patients that are PD-L1 negative, is that something that might be useful and to help predict patients that might respond? Outside of immunotherapy, there are other genomic biomarkers that are promising that I think have some data around them. For example, MET gene amplification, EGFR gene amplification, FGFR2 gene amplification. These are all receptor tyrosine kinases akin to HER2 gene amplification, where we already know that in the first line setting, anti-HER2 monoclonal antibody with trastuzumab leads to improved outcomes when combined with chemotherapy. There are a number of smaller phase 2 studies that show pretty consistent response rates in a subgroup of these, not all of them, but in a subgroup of each of those biomarker groups that I think is worth mentioning. Then in terms of biomarkers of prediction for anti-angiogenesis therapy, this has been elusive not only in this tumor type and across tumor types, where efforts over the last decades have been led to try and find what a predictive biomarker might be to help enhance or enrich for benefit amongst those patients getting anti-angiogenesis therapy. But they have been very elusive, a number of biomarkers, and there's no routine biomarker implemented to date to help enrich patients that might benefit and spare others. And in fact, my sense is that there is sort of a modest benefit that is across all patients, and that it's not in a subgroup that you see just a remarkable benefit and others not. It's just sort of it's different than other targeted therapies where, in fact, if you don't have the biomarker, say, for example, HER2 amplification, anti-HER2 therapy is not going to be effective. And if you do have it, then you will substantially enrich for benefit. I think anti-angiogenesis drugs work slightly differently. They modify the tumor microenvironment, and so they sort of work sort of generally across all tumor types to a modest degree.